Okay, good morning, good afternoon, and also good evening, depending on where you're listening to this slide presentation. Okay, so my name is Victor, and this is the Cisco CyberOps, or what we call the Cisco Cybersecurity Operations Associate Certification Training. Okay, it's about 28 modules, and we're right now in module 6. We've looked at the danger with regards to what are those threats that we have within our IT infrastructure. Then later on, we looked at the who are those guys that are going to help us protect our systems. So the SOC team, that is the Security Operations Center team. So what are they made up of? So you have the tier one, you have the tier two, you have the tier three, and of course you have the SOC managers. Then in module four, three rather, we looked at Windows, the Windows operating system. Now we know that for with whichever network or hardware or application or IT gadget or anything that is going to help you hold data, transmit data, process data, it's going to have an operating system in one form or the other. So what are the three major operating systems? So we have Windows, Linux, and Mac. So the goal is to be able to understand these operating systems that are going to house our data. They can be personal identifiable information. They can be health information. They can be records. They can be intellectual property. Whatever it is, what is going to hold our data? We normally have an operating system. So that's one of the reasons why we start looking at the Windows operating system, the Linux operating system. And for whichever case, these operating systems have their vulnerabilities. So what are those things that we need to do to better understand the operating systems, see their weaknesses and see how to patch them and create a better secured environment? Then later on, we started laying some foundation with regards networking, because you cannot do cybersecurity without having firm grip of networking knowledge, of web programming knowledge. You need it, because whatever data you have is going to sit on a network, it's going to sit on a PC, it's going to be transmitted over the internet, it's going to maybe sit on application or attack an application. So that's why we started looking at the OSI model. I gave you a mnemonic. I love potatoes a lot. I mean sweet potatoes. Some people will prefer the Irish potatoes. So please do not take sweet potatoes alone. So I go from down up till the last layer, which is the application layer. You want to do more research, and please log on to your LMS and get to familiarize yourself with the modules, take most of the quizzes. If you have questions, please log into the mentorship group and ask your questions. So in module 6, we're going to go very swiftly. We're going to be looking at Ethernet and Internet Protocol. So what's actually our goal? We want to be able to, like now, if you see most of the items here, the goal is for you to explain, for you to understand. You may not be doing any configuration, setup. Good understanding and you being able to explain will help you as a cybersecurity expert, as a tier one or a tier two technologist. So you should be able to explain how Ethernet supports the network communication, what is IP version 4, IP version 6, and what do we mean by default gateway. So don't forget, I said please do not take sweet potatoes all in. So that is my mnemonics. So Ethernet is the first two layers. So like I said earlier on, you want to understand whatever that is happening within your SOC team, or rather within your SOC, your Security Operations Center. For every data that is being transmitted, you want to understand at what layer is that guy playing. So here, unlike wireless, Ethernet uses wired communication. So this is at the physical hardware layer. Your Mac, your LLC, your switches, all of your cables, the different type of cables, they all operate at this level. So we are saying that for you to have communication, your hardware is the first thing. That's why also when you're troubleshooting, you can decide to go from bottom up or top bottom. So you can start to say, is my hardware okay? Is my cable well crimped? Is my coaxial cable? Is my switch okay? Then before I start moving to my router, moving to the transport layer session, presentation, how is it being presented? Then first start looking at this particular software application that is in charge of that particular data you're after. Now we have frames, right? So MAC address, for instance, to say it's 48 bit. But for Ethernet frames, we have between, it can be 64 to 1518 bytes. So for your exam, you want to be able to understand uh, what IP address, what layer do you have MAC address, and why do you need to do frame check sequence, right? Sequencing is important because if you have so many information you want to transmit, you need to put them in kind of an hierarchy, an order, so that you don't have collisions, you don't have issues. Okay, so what are the frames? So you have them here: preamble frame, the destination MAC address. So for communication, you need all of this. For instance, you can ask me what's my name. For instance, if you want to put 20 persons into a job role, you're going to be asking them your name. So their job role is that like their destination. Where are they? Where are you heading? Where are you heading to? Where are you taking them to? Where do you want to post them to? Maybe upon recruitment. So the first thing you're asking is that what's your name? What's your degree? What specialty do you have? Any identification number do you have? What's the length of your year? What's the years of experience? Blah blah blah. Right. So you just grab as much information as possible. It's just to aid communication. So this is it: preamble, destination, source MAC address. Because if I don't know, if I have a packet of data, I don't know where it is going to, then you're going to have the packet dropped. So you need to gather and collect the information about where it is going to and where it's coming from. Then, of course, all that data. Of course, some frame check sequence, right? So that's it there. So this is your MAC address. Like I said, the MAC address is a 48-bit operating system. So this is decimal, binary, hexadecimal. So this is what the MAC address looks like, right? If you want to have it with dashes, it can be this way. So if you do network packet analysis, or if you scan your network, most of the hardwares you're going to have are going to have anything that is going to have internet must have a MAC address. If it's on a network, on a routing network, it's going to be assigned an IP address. So you have an IP address as an identifier for a particular packet of data where it's coming from or the source. You also have IP address as an identifier. So there are several things that identify items on our network. So MAC address is one of them. So if I know your MAC address, I can block you off the network. I could filter data that's coming from you. I can restrict data that is going to be sent to you. There's so many things you could do. That's one of the advantages of the MAC address. And the MAC address at times we call the physical address. Yes, that is called the physical address because that is ingrained in the hardware of the MAC address. Of course, you have I think titanium, if my spelling is correct. You could just put this on Google, it's going to give you the correct name. So there are softwares that you could use to change up the MAC address of but it's actually going to be virtual. So intelligent switches and routers will definitely flag that as a cloned or a spoofed MAC address. So IP version 4. So once you get to this layer, the layer 3. So you count the OSI model from down up. So physical layer data link, please do not take sweet potatoes alone. So please don't take it alone. Anytime you're taking sweet potatoes, please pass it on. That's by the way. So you have the third layer, which is your network layer. So there are so many things that happen in the network layer. That's where you have your IP version 4 and 6. That's where you have your router. That's where you have IP cameras and the rest. So they operate at this layer, whereas your switch operates at this two layer. Your physical hardware, fiber optics, Ethernet, whatever, they operate at this level. Okay, so I think so this just explains well, when we talked about data encapsulation and data de-encapsulation. Just for these two guys to communicate, it has to go through from the very top to the bottom. And this is a video simulation. Please, I would love you to log on to your LMS and watch most of these short simulation videos. I explained IP encapsulation, so you can apply that to IP like I explained in the previous model. Characteristics of IP address. So there are some things you need to understand as regards IP address, which is like an addressing system. So if I need to communicate, I need an IP address. If I need to communicate, I need a MAC address. If I need to communicate, I need port numbers, protocols. So IP addresses are connectionless. It's best effort. It's media independent. So whether you're using fiber optics, you're using wireless, you're using Bluetooth and wherever, will you be able to get an IP address via Bluetooth? Yes, I think yes, you can. So whichever way you connect, you're going to be assigned an IP address. So I talked a little about the connectionless ideology, right? So we're saying that IP address don't need to establish a connection, right? In order to send message, it just gives the letter an address. There's no dedicated end-to-end connection created by IP before data is sent, right? Unlike a three-way handshake. So I know that the letter is meant for 192.168.8.10, right? I just start sending it. If I get there, I don't see the information, it can drop, right? It wouldn't say. So other protocols, don't forget we're trying to understand these protocols, Ethernet and Internet protocol. Try to understand how it works. So for this guy, it's just basically an address. Okay, so that's the principle of best effort. It's media independent. It doesn't have to do with which kind of connection you're using. Your IP address is your IP address, whether you're using Bluetooth, you're using wireless, using copper serial cable, and the rest. So what are those headers? We looked at what was it called? The Ethernet headers. Now we're looking at the IP version 4 header. So for the first thing you have is version, differentiated services, header checksum. So the checksum is going to get some kind of ID, right? Time to leave, how long? 13 seconds, 50 seconds before you drop it. So it's just like I have a property, and the property have an expiry time. So that's like the time to leave. That's my address. It's not going to be my address forever. So it's going to always have the time in which I've paid, and I would not have to renew. Same thing with an IP address. It has a time. So that's what you call the time to leave. Of course, the protocol, and whether it's going to be IP version 4 or IP version 6. Addressing basics. So anytime you see an IP address, understand that this is the network portion and this is the host portion. That's why you can see somebody saying 192.168.10.1, 10.2, 10.3. So all of these 1, 2, 3, 4, 5 are all nodes on the network. Whereas this guy represents the network. If you ask the question in the exam, for instance, saying 192.168.10.5, 192.168.10.3, 192.168.20.10, which of them are on the same network? Those first two I mentioned are on the same network. That other one that has 20 here are not on the same network with these two others. Okay, I need to write it clearly so that you understand. 192.168 8.1. 192.168.8.5. 192.168.10.8. 192.168.10.5. 192.169.10.1. Now, the guys in red are all the network portions, whereas the guys at the end are all the end device. That means that you can have phones. This is my phone. This is my printer. Of course, here now, this is another network altogether. So this is network one. Hope I'm not rusty with my basic design skill. Okay, I'm gonna take this guy out of text, put this guy inside. This guy. All of these guys, they are all in one network, right? It then means I can have a switch here connected to a router, a switch here connected to a router. These are two networks. Why? This is the host portion. This is the what? Rather, this is the host portion and this is the network portion. Here, this is the network portion, the guys on red or in red, and these parts are the network portion. Okay, let me take this away. Wow. Okay, so it makes sense. Let's write on. Subnets. So to assign IP version of 4 address to a host requires the following. You need an IP version 4 address, then you need a subnet mark. So this is what we use to identify the network portion and the host portion. Okay, so this is the binary. This is the binary, right? So 0 in binary is equivalent to this. 255 in binary is equivalent to this. Okay, prefix length. So the prefix length is the number of bits set to 1 in the subnet max. I will see how to get you a table that atomizes the different IP version 4 addresses, their different subnet max, and the different IP classes. So classes of IP. I'll get you that document so it's easier for you to understand. Classes of IP addresses. Okay. So are you seeing? So if I say a /8, I think I don't need to get you an extra document. So if I have a /8, this is a subnet max. So you have /16, this is it, /24. So you want to combine this. If you convert this to this, after you actually you go from here to here, then to here. So if you count this 255, convert it here, you have your 8. So if you count, this is 8. If you have 255, another 255, if you count 8, this is 16. If you have another 255, 255, 255, you count, this is 24, right? So this is a typical class C address. So this is the one of the most common, right? All the way down like this way. Okay, so this is what to call ANDing. So this is a little bit of logic. So there's a way I explain this to my students because this is Boolean. If I ask you N and AND, what do you get? 0 and, or rather plus, I get 0. So the one of the easiest way for you to evaluate this is by saying, if I have a 1 and I'm asked if an equation is true, and true is always true. If they say this equation it's false and 1, of course you're going to have 0. Same way down. You can have the same logic as per replicate this as per or. So you need to learn some logic. Say this or this. So any of them, if it's true, you get 1. This or this, of course, you get 1. Right? So they're saying this can be correct or this can be correct. You get 1 can be correct, and or this, of course, you get 1. This or this, you get what should this be? I am a man, or okay, sorry, I'm not a man, or I'm not a man, or I don't live in Amsterdam. So I think I should have a 0. So you can confirm this. Okay, so that's just a little bit of logic there. Um, so applying that and then here. So trying to use that in terms of each of these, and so depending, this is my 8-bit, 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 8-bit. Of course, that's why you say IP version 4 addresses are 32-bit addresses, because 8-bit plus 8-bit gives me 32 plus another 8-bit plus another 8-bit. Sorry, 8-bit plus 8-bit gives me 16. Another 8-bit, I think 24. Then another 8-bit, I have 32-bit. So that's why you say IP version 4 addresses are 32-bit. IP version 6 address are 128-bit. Then of course MAC address is 48. Okay, so please, there is a short video, I think it's about 3 or 4 minutes in your LMS. Please make sure you read this and revert if you have any questions. Okay, subnetting broadcast domain. So in this figure, LAN 1 connects, this is LAN 1, it connects 400 users that could each generate broadcast traffic, which can slow down network and device operation. The solution is to reduce the size of the network, right? You don't want to lump sum. So that is called network segmentation. It helps to provide security. It helps to reduce the broadcast domain. So it helps to, because once everything is on one broadcast domain, what's going to happen? Everybody's going to be sending packets down to that particular switch. But if things are not segmented, because if things are segmented, they can route their traffic properly, and you have a more efficient network and reduce load. You can also use VPN to achieve this, right? I think the Cisco routing and switching wireless essential course, VPN is explicitly discussed, defined in that course. I think you also need to know how to do these configurations. It's a very straightforward thing. For a cybersecurity expert, you being able to explain will suffice. Because VPN is also or rather VLAN, I mean to say, it's also a security measure to better protect your network, provide so that what VPN is that I have 10 ports on my switch, right? So I can say any cable I connect into port 1 is for marketing. Any system I connect it to 3 is for IT. 4 is HR. So you can have run same thing VLAN commands on all of the switch you have across your router. What now happens is that you've now segmented all the administrative stuff in one VLAN like that. It helps you for better network administration, right? Privileges and the rest. So you have different types of IP addresses. I think I mentioned the class C, which is the most common, right? So you see that we could have up to 254 hosts. For class B, 65,000 hosts. Then for class A, 60 million host addresses. Okay, so this is what it looks like. So class A, which is 50%, right? Total networks is what you can take. C is what you can take. D, which is also common. D and E, this is what they can take in terms of IP addresses. So you also have some private IP addresses. So you could purchase an IP address. For instance, if you have a website, you could decide to say, I want to buy an IP address for my website, a private IP address. I don't want to use a shared IP address. Yes, you're going to be given that, you pay for that. If you are using any of the ISPs, internet service providers, and you want to access the internet, but because if you connect through the regular gateway, you're going to be sharing IP address with every other person. Maybe persons that do hacking, persons that send emails, persons that spam the internet, the networks, and the rest. So you don't want that. You want a dedicated channel. So you could purchase a private IP address from your ISP. Also, I think that's a quite a number of ways that IP addresses can be implemented. Okay, so reserved, default gateway. So what do you call it default gateway? So reserved, what's it called? IP addresses. So there's some IP addresses that are never going to be given out, so they're going to be reserved. Okay, default gateway. So how am I going to connect through to another network? That's what your default gateway is. So most of your router is your router that performs that function because the router that connects you to other networks. So it's normally local IP address in the same network or at other hosts on the local network. So most of the times your default gateway is going to be point 1. So if you have 192.168.8 points, your default gateway is going to be 1. So every other system is going to pick after that particular IP address. So you see, it accepts data into the local network and also forward you out of the network, right? It can also forward you out of the network. That's the goal. That's the function of a default gateway, normally performed by a router. Okay. Okay, so this is a further explanation of that. So like I said, PC1, PC2 are configured with the IP address of this as a default gateway. So this is my router. This is my switches. So IP version. So PC1, PC2, they're connected to a switch, but they are configured with the default gateway of this R1, this guy, 192.168.10.1. So if that's the case, you have to configure default gateway on these PCs as 192.168.10.1. That's the only way these guys can live to or connect to other networks through this router. You could configure it manually or dynamically. We saw that in the last class. Okay, routing table. So what is contained in my routing table? So it just gives me information about most of the IP address I have, their interfaces, and at times it's going to contain MAC addresses, right? It's just for it to be able to route and connect PCs to other network or help PC connect between themselves once they're on the network. IP version 6. So the reason why we have IP version 6 is because we are exhausting the capabilities of IP version 4, which is roughly about 4 billion IP addresses. So, but what's helping us achieve that majorly is NAT, network address translation. I explained that in the last class. I said NAT is what's responsible for translating all of the address we have within our network and being able to push us outside of our network. So that's what does translates your local IP address, the one you get when you do IP config, and your public IP address, the one you get when you type my IP address on Google. So it's because of several endpoints that we have as a result of IoT, more devices. So that's one of the reasons why we have IP version 6. So it has more usage, right? It can accommodate more endpoints. So don't forget it is 128-bit. So I said Mac is what? 48-bit. IP version. Sorry, don't mind me. I'm saying IP version. So IP version 4 is what? 32-bit. And IP version 6. Version 6 is 128. Let's take that. 1, 2, 3, 4, 5, 6, 7, 8. Just a moment. Okay, so each of these is 16 bits. So if you check 16 bits by 8, you get 128 bits for IP version 6. Okay, so this is what IP version 6 looks like. It's just kind of lengthy. There's actually a way of reducing and making it readable, because if you go to your PC and you do IP on your command line interface and you type ipconfig, you're going to get IP version 6 address if you're connected to a network. But it's not going to be as long as this. It's going to be compressed. Okay, so this is one of the ways you could compress it. So if you have something like this, as lengthy as this, so you omit leading 0. That's the rule 1. If you want to make it shorter, smaller, the rule is that, for instance, this one is 2001, you keep it. Any 0 that is leading several digits, you take it off. So this is what you have. This one, you take all of these zeros, just leave 1. This one remains. Take all of these 3, just all the leading zeros. This one remains. This one remains. This one remains. This one goes off. This one remains 200. So once you have that, the rule 2 is double colon. So double colon can replace any single continuous strings of 1 or more 16-bit hex text consist of all zeros. So I have all zeros, all zeros, all zeros. So I replace by double colon, right? Even if I have all 0, all 0, all 0, all 0, I'll still just use only 2. You see, at the end of the day, I've shortened and I have this as the compressed version of the IP version 6 address of this long guy. So most of the times IP version 6 address are not written like this, they're written this way. But this is just a process to tell you how to compress. Okay, prefix length. This prefix length like we said, for you have the first section, which is the prefix, and the second section, which is the interface IED. So this 64-bit, 64-bit, if you join them together, it's going to be 128, right? So please get your LMS and watch the video that tells the difference between layer 2 and layer 3 addressing. So layer 2 has to do with MAC, address, and the rest. Then layer 3 has to do with IP address. Okay. So summary, what have we learned? We've learned about LAN, we've learned about IP version 4, IP version 6, we've learned about MAC address. We've learned about data encapsulation, routing, and the encapsulation. They've understood that IP version 4 is 32-bit, IP version 6 is 128-bit, the MAC address is 48 bits, right? 48 bits. That'll be all for Module 6. Thank you very much. See you in Module 7.